Assalamualaikum and hello everyone. Welcome to the video for 3.1 Galvanic cell, where in this video we will learn to define electrode potential, define standard reduction or electrode potential, and define standard cell potential. Draw and explain the standard hydrogen electrode and use the standard reduction values to calculate the standard cell potential. Okay, so that's quite a lot of potential. Now let's look on your notes on page 4. So here is the definition. What is the electrode potential? It is the potential difference between the two half cell in an electrochemical cell. Okay, based upon the galvanic cell or the voltaic cell, the component for it, we know that it must contain two half cell, one anode, one cathode. Another is our salt dish. And then when this reaction occur, we can record, it will produce a voltmeter reading here, which we can record it, and this is what we call as the electrode potential. Or it could also be called as cell voltage or cell electromotive force. Okay, so for the standard electrode potential, still the same definition, the potential difference between the two half cells, but then again, because we have here standard, so it means that the reaction must occur at standard condition where the concentration of your electrolyte must be 1 molar, the pressure of the gas must be 1 atm, and the temperature must be 25 degrees Celsius. Okay, so that's the definition. Okay, next definition that we will look at is the standard reduction potential or the SRP. The standard reduction potential is defined as the reduction potential obtained again at standard condition. Okay, standard condition, concentration electrolyte 1 molar, pressure 1 atm, temperature 25 degrees Celsius. Okay, mostly we will use this standard reduction potential or SRP. Okay, so for the SRP, so let's look on your notes on page 5 here. Okay, for the rest of chapter 5, usually the SRP is given to you. Usually you will denote as E0 here. So why this is called as SRP or the reduction potential? Because all of this value is given is when the species undergo reduction. Now all the species here, as you can check one by one, all of it will undergo reduction. Okay, so that's why we define it as SRP. But usually in your notes, you will just denote it as E0 of your cell itself. Okay. Okay. Based upon the SRP, here it mentioned that changing the stoichiometric coefficient does not change the value of E0. Okay, for example, I have my Cl2 gas plus 2 electron will become 2 mole of chlorine ion. So the E0 will be positive 1.36. Okay, when I divide this value, divide by 2, so I will get this equation, which the E0 value is still the same. So here it mentioned that the changing the stoichiometric coefficient does not change the value of E0. Okay, when we learn back in chapter 2, when we learn about Hess law, okay, if we have an equation, and when we divide it by 2, the delta H must be divided by 2 as well. But for the case of E0, it will not does not change the value of E0 when we divide or multiply the stoichiometric coefficient. However, the sign of the E0 will change when the reaction is reversed. Okay, for example, here half Cl2 gas plus electron will become Cl minus. Once I reverse it, okay, the E0 will be reversed as well. For example, here is positive 136. When I reverse it, I will get a negative 1.36. Okay, that is for my SRP. Okay, here I'm just going to be focusing on this part just a bit. Okay, from the page 1, from the introduction, we have learned about the anox oil and bracket grid. So anox, anode is where oxidation occur, where oxidation is losing electron. Reduction occur at cathode, where the reduction is gaining electron. Okay, so from here, how to know whether the species will undergo oxidation or undergo reduction? Okay, for the anode or oxidation, okay, just for you to remember anode. So here anode negative. Just to remember N negative. So when E0 is negative or more negative, it will prefer to undergo oxidation. Okay, again, for here, cathode. Okay, because cathode here, just remember that positive. The T positive here. So when the value of E0 is more positive, so it means that the reaction would prefer, or the species would prefer to undergo reduction. Okay, here. Here is another one information that you have to add. Usually yang ni je kan that I like to emphasize. Okay, now we're talking about the E0 negative for Eᵒcell, E0 positive for red cat rig. Okay, so that is actually for the definition. So now let's look for She, standard hydrogen electrode. Okay, so here it mentioned that E0 is measured by pairing the half cell with standard hydrogen electrode. Okay, so from here, as we can see, we know the E0 value for many species. For example, copper, zinc, magnesium, silver, cobalt. Okay, so how do we get this E0 value? And each of it we have different value, kan? How do we get it? It's actually when we pair this half cell with our standard hydrogen electrode, or She. Okay, standard hydrogen electrode consists of hydrogen gas at 180 m bubbling around a platinum electrode which is immersed in 1 molar of hydrogen solution. Okay, so here is the example of your half cell of your She. Okay, for the half cell, we do need our solid electrode. Okay, however, for this case, we only have hydrogen gas and hydrogen plus aqueous. So that's why there's the presence of our platinum electrode, which is an inert electrode. It will not be involved in the reaction. Okay, so again, She is used as a standard reference electrode to measure the E0 value of other half cell. Okay, why do we use it to measure the electrode potential of other half cell? Because the value of She is assigned as zero potential. Because the value is zero. For example, here if I have my E0 is 1.27. Because I know my She is 0 volt, so it means that my copper sulfate is the one with 1.27 volt. Okay, so that's why She is used as a reference. Okay, when She act as an anode, so here will be the equation. Again, anode where it will lose electron. Okay, so this is the equation at anode. And when we write down the cell notation, just remember A, B, C. So for the A, B, C, for the cell notation, okay, here we have hydrogen gas and H plus aqueous. So this is our species. Okay, why do we start with platinum solid? Because remember, for the cell notation, we have to start and end with a solid. So that's why we have platinum here. Even though the equation does not involve platinum, we have to include it here because we have to include the electron. When She as a cathode, okay, A, B, C. So again, here will be the N1. Okay, but then the H plus will become H2 gas. And then because again, cell notation start and end with a solid. So here the N must be a solid, which is our platinum solid. Okay, so that is for the explanation. Next, what we're going to look at is to calculate the standard cell potential. Again, what is the standard cell potential? It's the cell potential measured at standard condition. Okay, so for the calculation of Eᵒcell, it is Eᵒcell is equal to E0 cathode minus E0 anode. Okay, ataupun senang nak ingat, ini kakak tolak adik, E0 kakak tolak adik, ataupun boleh juga E0 cucu tolak atuk. Ini macam jahatnya cucu tolak atuk, bayangkan tolak wheelchair lah. This one, I would prefer to use this one. Or we could also use it Eᵒcell equal to E0 reduction plus E0 oxidation. Okay, so the first example here, let's do it together. Okay, now let's do the calculation together. A, calculate the standard cell potential. There are two formulas that could be used. So I'm going to use for this example A, I'm going to use for both lah. So the first one is the Eᵒcell is equal to cathode minus anode. Okay, but which one is cathode, which one is anode? Okay, so remember that E0 negative. So negative, you will prefer to be the anode. The N. So that will be your anode. So which one is the negative 0.76 volt? Okay, so for the cathode, we prefer to be the positive one because remember the TT. So that one is the positive 0.34 volt. Okay. So once I know which one is which, so we can use it straight away into the formula. Eᵒcell equal to Eᵒ cathode minus Eᵒ anode. You could also write it down as Eᵒ cat minus Eᵒ n. Or another way to remember it, Eᵒ kakak tolak adik, cucu tolak atuk. Then we can substitute it straight away. So we will get the answer quite straightforward. It will become the answer will be positive 1.10 volt. So the positive must be included to show that the reaction is spontaneous or this reaction could occur. Okay, so that's the first method. It is quite straightforward. I believe this one, it will be the method that you're more comfortable with. Kakak tolak adik, cucu tolak atuk. Okay, the second one is Eᵒcell equal to Eᵒ reduction plus Eᵒ oxidation. Okay, so from this one, you have to determine, you have to change the equation. Okay, so for the first one, that is the equation for the cathode, where the reduction occur. Okay, so it means that the other one is the Eᵒ oxidation. Okay. So first, what you have to do for the second formula is you have to write down the equation again. So for the first one, okay, remember reduction is gaining electron and this equation is gaining electron. So what we will do here is we will write it down all over again. The Cu2 plus 2 electron, we will get copper solid. But then please include the Eᵒ value. Okay, this is the Eᵒ reduction. Is positive 0.34 volt. Okay, next is oxidation. Okay, oxidation, but then why does it gain electron here? Okay, because remember, kalau oxidation, oxidation is the one where lose the electron. So we have to change the position to get the oxidation equation. We want to lose the electron. So we change the position itself. So we do get our oxidation equation. How about the Eᵒ value? So the Eᵒ value have to change because the position is changing. So it will become positive 0.76 volt. Okay, so that is the equation and the value. Okay, then you can substitute it straight away where the Eᵒcell is equal to Eᵒ reduction plus Eᵒ oxidation. So again, you have to take where the Eᵒ reduction plus Eᵒ oxidation. You cannot take straight away from the Eᵒ value. So when you add in all the value, you will get the same answer, which is equal to positive 1.10 volt. Okay, so again, it has the same answer, but this one has more steps than the first one. So choose which one you're comfortable with. So I believe it's the first one. Senang lagi, kakak tolak adik, cucu tolak atuk. Okay. So that is just that for you to remember for the cathode. Okay, the cathode will be preferred to be a positive, negative, the anode one. Itu sahaja yang confused dia. Tapi again yang lain straightforward saja. Example B, C, I believe you could try yourself. For example D, this value for both is negative. So again, if the value is negative, remember we have to change it in terms of, we're going to compare between this value. For the cathode, we prefer it to be the more positive value. So which one is more positive? Is negative 0.13. More positive when the value is nearer to 0. Okay, the anode is the one with more negative. So we get negative 1.66 volt. Okay, so that's it for the example. I believe the rest you could try yourself. So that's it for this video.